The question about wall calendars and pocket calendars was probably as tricky as we're going to get because you had to figure out the profit and they didn't give you a whole lot of straightforward information. So they will get a little bit easier, which is the good news. So the next one, a lunch stand makes 75-cent profit. So before I even keep reading, they're already giving you profit. That's good. On each chef salad and $1.20 profit on each Caesar salad. On a typical weekday, it sells between 40 and 60 chef salads and between 25 and 50 Caesar salads. The total number has never exceeded 100 salads. How many of each type should be prepared in order to maximize profit? Remember, your objective function comes from profit. So I'm actually going to start with this one this time. I'm going to start with the objective function because getting profit out of the way might help us when writing the constraints. So we do need to decide which one is which. I'm going to let x equal the chef salads, although honestly it doesn't matter. And that means that y is going to be my Caesar salads. Okay, so that very first sentence is where they gave us the profit information. The chef salads, which are x, are 75 cents each, so 0.75x. This is profit. Objective function is profit. And then $1.20 on each Caesar, so plus 1.2y. That's my objective function, the function that's going to allow me to find the total profit. We're going to have to pull across some constraints. First constraint, it sells between 40 and 60 chef salads. That means chef salads, which are x, are between 40 and 60. This is the sandwich inequality. Now, the Caesar salads, which is y, fall between 25 and 50. These are two constraints. It says the total number sold has never exceeded 100. Total number sold. So that means the number of chef salads and plus the number of Caesar salads, y, it says never exceeded. So that's less than or equal to 100. I'm going to work my way backwards on these constraints only because I have the blue pen in my hand. If you solve the blue inequality for y, you get y is less than or equal to negative x plus 100 because we're subtracting x from both sides. Now obviously my scale is a mess. I don't have 100 blocks, but I do have 10, and it looks like everything will stay nice there. So I'm going to take a second at the bottom of my graph, write all scales by tens. I'm also going to take a second to label my x-axis chef salads and my y-axis Caesar salads. So for that blue inequality, it starts up 10. Remember, we're going by tens. Everything's by 10. So I'm going to start at 10. That's my y-intercept. And because I have all scales matching, I can go down 1 over 1 a bunch of times until I can draw in a solid blue line. Now this is less than that blue line. So at this point, and I'm going to get rid of this in a second just so you can see it, at this point, this is where I am because it's below the blue line. So just keep that in mind. I'm in that triangle section right now. All right, I guess I'll do the green one next. The green one falls between 25 and 50, and it's a y value. When you have an inequality or an equation that only contains y, those are horizontal lines, which means I need a horizontal line at 2.5 and another at 50, which is 5. And my shading occurs in between those two lines. So at this point, I'm stuck all in here. I was below the blue line and in between the green. So that's where I am currently. Now we do have one more set of constraints, and that last one is the one for the red side. The red side, which in this case is chef salads, is falling between 40 and 60. So a straight line at 40, 4, and a straight line at 60, 6. And again, I want to be in between there. So now my shading is a lot smaller. I'm in between the green and the red, but below the blue. That yellow section describes my feasible region. Now, vertices, I have 1, 2, 3, 4, and 5. I'm going to list those ordered pairs. I'm going to start at the top left and work clockwise. That top left ordered pair is 40, 50. Remember, I'm going by tens. And then again, working clockwise is 50, 50. The third one looks like it's occurring at 60, 40. Then the fourth one is occurring at 60.25. Remember that was at 2.5. And then the last one's at 40.25. Those are my vertices. And we have to evaluate the objective function for each of those vertices. So take a second, pause the video, and evaluate the objective function, which I had at the top. I'll scroll up so you can see it. It's that 0.75x plus 1.2y. I'm going to put all of those vertices in 0.75x plus 1.2y. Take a second and look over the values that I got. The first three are relatively similar. Last two come in a little low. But you're looking to maximize your profit. You're looking for the biggest profit. And that biggest profit occurs right here at 50/50. So to write your answer, you're going to write 50 chef, 50 Caesar, max profit, and then give the value with dollars, of course. That's the label. That's it. I would say most of the linear word problems that you're going to see for linear programming are going to look more like this. A little bit easier to find in terms of profit. Okay, I'll do the last one with you as well. We'll skip the You Try It's for today because this lesson is a little bit more difficult. We're screen printing t-shirts and sweatshirts to sell at the Polk County Blues Festival and are working with the following constraints. You have at most 20 hours to make shirts. You want to spend no more than $600 on supplies, and you want to have at least 50 items to sell. A one-color t-shirt takes 10 minutes to make. Supplies cost $4. You make $6 in profit. I'm going to take a second and actually in orange just box all my profits so that I don't touch them again. A three-color sweatshirt takes 30 minutes to make. The supplies cost $20. You make $20 in profit. Don't ever use profit in constraints. How many t-shirts and how many sweatshirts should you make to maximize your profit? How much is maximum profit? All right, we're dealing with t-shirts and sweatshirts. So I'm just going to take a second. I'm going to let X be t-shirts. Y will then be sweatshirts. Just keep that in mind. We got X for t-shirts and Y for sweatshirts. Okay, those numbers that I did in orange are going to be my objective function profit. So each t-shirt is going to make me $6, that's 6x, and each sweatshirt will give me 20, so 20y. Let that objective function kind of sit to the side. That will not be part of my constraints. Okay, first constraint I see, and they listed them in a bullet format for you, which is kind of nice. I have at most 20 hours to make shirts. Here's the tricky part about the 20 hours business. So they tell me it's 20 hours to make them, and then later on they say, okay, well it takes 10 minutes to make those and 30 minutes to make those. Hours and minutes don't match. So before I keep going, I'm going to take a second and say, okay, well 20 hours is 1,200 minutes. 60 minutes in an hour times 20 is 1,200. Now, that's how much time I have. It says I have at most 1,200 minutes. Each of the t-shirts takes 10 minutes, so 10x. And each of the sweatshirts take 30 minutes, 30y. And I need that to be less than or equal to 1,200 because I have at most 1,200 minutes. Now, the next piece of information they tell me, I want to spend no more than $600. That's how much I'm spending. Okay, well, how much I'm spending to make a t-shirt says it right here. I lost my highlighter. It costs $4 for a t-shirt and $20 for a sweatshirt. So, my constraint, 4x plus 20y, because I have no more than $600, is less than or equal to 600. And then the last thing they're telling me is I want to have at least 50 items to sell. Now this one doesn't quite work the other way because I don't have anything in terms of paragraph information left. So if I want to have at least 50 items to sell, that means that x plus y has to be greater than or equal to 50. So again, I'm going to start with the blue one because my marker is blue already. If you solve that for y, you get y is greater than or equal to negative x plus 50. It looks like this one's going to be best to be taken by tens as well again. So I'm just going to make a note of that at the bottom. All scales by 10. So for that blue line, I'm going to start up 5 and go down 1 over 1. My slope is negative. And at this point, my feasible region is going to be above that. So at this point, I've got all of this. It's above the blue line. It's not something we're used to. Just keep that in mind. I've got a feasible region that's above the blue line. The next inequality I'll do is the green one. Take a second, pause the video, and solve that for y. You should have gotten y is less than or equal to negative 1/5 x plus 30. That's a line that crosses at 3, because we're going by tens, go down 1 and over 5. And for this green one, I want to be below. So now we're really kind of odd. We're below the green line, but above the blue. So our feasible region is in a position that we're not used to being in. And then the last one is red. Again, take a second, pause the video, and solve the red inequality. You should have gotten y is less than or equal to negative 1/3 x plus 40. That line crosses at 4, goes down 1 over 3. Crosses at 4, goes down 1 over 3. Now, 2 inequalities that we didn't talk about, I'm pretty sure I actually forgot now that I think about it. I'm pretty sure I forgot to add them to the last one, and I'm pretty bad at this. I probably shouldn't be, but I'll admit it. The first one, don't forget that every time we have these, we should be adding in, x is greater than or equal to 0 and y is greater than or equal to 0. Because you can't have a negative number of t-shirts or sweatshirts or anything else. So remember back to our shading, we were below the red, below the green, but above the blue. So our feasible region is right in here. All right, so my vertices, there's one here, 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 that's interesting, we're not used to that, and here. Okay, so I'm going to start again at the top left and work my way over. That one looks to be about 25, 25. Working my way over, I'm looking at this dot right here. I'm trying to make it a little bigger so you can see it. That looks to be about 75, 15. All the way over here, I'm going to call that 120, 0. I want to talk about that for a second. That's not part of our feasible region because, oh no, just kidding, I lied. I got distracted, I'm sorry. I'm guessing that's to be about 12, 0, which makes it 120, 0. And then this last one is going to be 50, 0. So again, please take a second, pause the video, and evaluate our objective function, which I had written above, 6x plus 20y, and find the profit for each. If you take a second and you look over the values that we have for our objective function, it looks as though our maximum profit is going to come from the ordered pair 75, 15. Now, I was a little nervous because our second runner-up was 120, the one that I had discovered, I thought, was 120. But you'll notice even if you made that a 125 or made that a 110, like if you're guesstimating that it's 12, even if you made it 11 or 12.5, it still wasn't the maximum profit. So I'm fairly confident that I've got the right ordered pair. So 75 stands for t-shirts. So you're going to have to sell 75 t-shirts, 15 sweatshirts, although I'm going to run out of room. I'm sorry, this is sloppy. Max profit will be $750. Make sure that you list that out. That's part of the solution.